Alright, this lesson is about something called direct variation. The entire thing is pretty much just defining something and then figuring out how to use it. But direct variation is a specific type of a linear function. So it's a linear function that does not have a y-intercept, or rather, the y-intercept is always 0. So instead of y equals mx plus b, it's in the form y equals kx plus b, but there's no plus b, because that equals to 0. So that's why they use the term k, and also because it's not just the slope, it's called the constant of variation. But as with any slope, the k value is going to be constant. So when you have an equation of a line, 2x plus 3, the slope isn't going to change. X and y values change throughout the line, but the slope is always going to stay the same. It's a constant. So when you have constant variation or direct variation, you have this constant, this thing that never changes, and that's going to help you find if you have direct variation or not. The equation y equals kx can be written like this: k equals y over x. And it's just showing the ratio between y and x. It's saying the ratio between y and x is always going to be the same. It's going to be some number k. So let's look at an example of that. When you have a table, you can look and you can say, okay, what's the ratio of y to x? Well, in this case, 8 over 2 is equal to 4, which is equal to 12 over 3, which is equal to 20 over 5. So you can see from this table we have direct variation because they're all equal to the same thing. They're equal to 4, the ratio of y to x. Another way to look at that is if you had x, to get from 2 to 8, you would have to multiply x by 4. 2 times 4 gives you 8, 3 times 4 gives you 12, 5 times 4 gives you 20. So this is direct variation. It's written like this: the constant of variation k is 4. So this is direct variation. This function models that table. Let's look at example B. What would you have to multiply 1 by to get 4? 4. 1 times 4 gives you 4. 2 times 4 equals 8. 5 times 4 gives you 20. So this is not direct variation. Another way to look at that would be 4 over 1 needs to equal 7 over 2 needs to equal 16 over 5. These should all equal k, but they don't all equal the same thing, so k would have to change, and it can't. It's constant. It always stays the same. So that is not direct variation. For each function, determine whether y varies directly with x. If so, find the constant of variation. So again, if y varies directly with x, it's just like a line, but where the y-intercept is 0. It has to go through 0. It has to go through the origin. If it crosses the y-axis somewhere else, then it's not direct variation. So when you have equations like this, you want to solve for y. So here we'll divide both these sides by 3, and you get y equals 2/3 x. Here you've already solved for y equals 2x plus 3. And then you have to look, does it go through the origin? Well, I could write plus 0 over here and you'd see, yes, that does in fact go through the origin if I were to graph that. This one's y-intercept is at 3, 1, 2, 3, and then it goes up 2 over 1. So it goes here, it doesn't go through the origin. So this one, yes, is direct variation. This one, no, it is not. And if so, find the constant of variation. Y equals kx, where k is the constant of variation if you have direct variation. So in this case, 2/3 is the value for k. K is 2/3. Example 3 is a real-world connection where they tell you that you have direct variation. So, a dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly with the amount of time the faucet drips. So we can write an equation from this second sentence. The amount of water wasted, so I'll call that A, varies directly with the amount of time the faucet drips. So you could write it like this: the amount of water wasted varies directly. That means you have k times the amount of time the faucet drips. So now we got to find the constant of variation and write an equation to model the direct variation. We already have our equation here, but we don't have K. Well, that's where this first sentence comes in. The amount of a dripping faucet wastes 1 cup of water, so 1 cup of water is the amount wasted if it drips for 3 minutes. So K is equal to 1 over 3 if we divided both sides by 3 here, and that's going to be cups per minute if we wanted to use the units. So the amount of water wasted in cups is equal to 1 over 3, I'm plugging in K back into this formula, times T. This is our equation for direct variation. Find how long the faucet must drip to waste 4.5 cups of water. Well, here was our equation again. How long does the faucet have to drip in order to waste 4.5 cups of water? Well, 4.5 is our amount, so we plug that in for A, and now we solve for T. To solve for T, you need to get rid of this 1/3, and so you can divide both sides by 1/3 since there's multiplication happening here, or you can remember that to get rid of a fraction, you multiply by its reciprocal, 3 over 1. So if I multiply both sides by 3, 3 times 4.5 gives me 13.5 is equal to T. Because these cancel out here, and you're just left with T on the other side. So 13.5, and then this is in minutes, remember? 13.5 minutes is equal to T. Alright, example 4, using a proportion. So when you have proportion problems, you can remember that y over x is equal to k. That's the same thing as y equals k over x if you divide both sides by x. Y over x is equal to k. And if you remember with our tables, every single one is equal. So when we had the table, I believe it was 2, 8, 3, 12, 4, 20, 5, 20. 520. It was 2 times 4. We did 8 over 2 is equal to 12 over 3 is equal to 20 over 5. Those are all equal to our constant of variation 4. We're going to take that idea and we're going to use these two problems. Every point is equal to a proportion. 8 over the y value over the x value is equal to the y value over the x value, and that's all the slope, or the constant of variation. So if y varies directly with x, we know it's in this form, and negative 51 over 27, that's our y and our x value, is going to be equal to our constant of variation, which is going to be equal to y over our x value. We don't know what x is when y is negative 17, but we know that these are all going to be the same thing. So the easiest way to solve this problem is reduce this fraction. Okay, if we divide both the top and the bottom by 3, you get negative 51 divided by 3 is negative 17, and 27 divided by 3 is 9. That's what k is equal to. Well, you can see here, negative 17 over 9 is equal to negative 17 over what? Well, it's obvious x has to be 9. And then the constant of variation, if they had asked you for it, would be this. That's as reduced as that fraction gets because 17 is a prime number. So that's direct variation.